Next question we have determine eigenvalue and eigenvector. Determine eigenvalue and eigenvector for given linear transformation. So first transformation we have L of xy transpose is equal to xyz transpose is equal to x minus y minus z minus x transpose. Solution. First of all, we will form a matrix A. So here it is a transformation, so I will write 1 minus 1 0 0 1 minus 1 minus 1 0 1 as matrix A. Now to find eigenvalue, I will write characteristic equation A minus lambda I is equal to 0. Determinant of A minus lambda I is characteristic equation. Now to solve this, 1 minus lambda minus 1 0 0 1 minus lambda minus 1 minus 1 0 1 minus lambda is equal to 0. On simplifying this, we are getting 1 minus lambda cube, then for this minus minus become plus 1 is equal to 0. So 1 plus lambda cube, actually this is minus lambda cube, then minus 3 lambda plus 3 lambda square, and this is minus minus, this is minus 1. Minus 1 is equal to 0. So this 1 and 1 get cancelled. So lambda cube minus 3 lambda square plus 3 lambda is equal to 0. On taking lambda outside, this become lambda square minus 3 lambda plus 3 is equal to 0. So first we have lambda is equal to 0. Second, minus b. So 3 plus and minus under root 9 minus 12 divided by 2. So this we get 3 plus and minus under root 3 minus 3, so under root 3 pi divided by 2. So we have eigenvalues as values are lambda is equal to 0, 3 plus minus root 3i divided by 2. Now to find eigenvector for these eigenvalues, so for lambda is equal to 0, eigenvector, first one, a minus lambda I into x is equal to 0. So we have a as 1 minus 0 1 minus 1 0 0 1 minus 1 minus 1 0 1 into x1, or we can say xyz is equal to 0 0 0. On solving this, we will get x minus y is equal to 0, y minus z is equal to 0, z minus x is equal to 0. This implies x is equal to y, y is equal to z, and z is equal to x. So we can write u1 is equal to x, y, z transpose. I can replace any of these. So suppose I write x as x, y as x, and z as x transpose. So x outside 1 1 1 transpose, when x belongs to R. So this is our first vector for eigenvalue lambda is equal to 0. Now to calculate next eigenvector, for next eigenvector lambda is equal to 3 plus and minus under root 3i divided by 2. So a minus lambda I, so 1 minus 3 plus and minus under root 3i divided by 2 minus 1 0 x y z is equal to 0 0 0. Now this is 0, again this is 1 minus 3 plus and minus under root 3I divided by 2 minus 1 minus 1 0 1 minus 3 plus and minus under root 3I divided by 2. Now on solving this we will get x minus 3 1 minus 3 plus and minus root 3I divided by 2 into x is equal to y 1 minus 3 plus and minus root 3I divided by 2 into y is equal to z, or 1 minus 3 plus and minus root 3I divided by 2 into z is equal to x. So here suppose this is the value of y. Now I have to convert z also in the terms of y. So y is in term of x, z is in term of y. So I have to convert z is also in terms of x only. So z is equal to, before that I can further simplify this as x 1 by 2 minus 3. So this become minus 1 plus root 3I divided by 2. How I done this calculation? 1 minus plus and minus as it is root 3I by 2, 3 by 2. So 1 plus and minus this. So 2 ones are 2, minus 1 by 2 minus plus and minus root 3I by 2. So this become minus 1 plus and minus root 3I divided by 2. Again z is equal to 1 plus and minus root 3I divided by 2 into y we has minus 1 plus and minus root 3I divided by 2 into x. So this become minus minus plus 1 plus and minus root 3I divided by 2's whole square x. So we have u2 as x remain x, y we have x minus 1 plus and minus root 3I divided by 2, and z we have 1 plus and minus root 3I divided by 2 square x transpose. On taking x outside we will get 1 minus of 1 plus and minus root 3I by 2, 1 plus and minus root 3I divided by 2's whole square transpose. So these are the three vectors for given linear transformation. So here I can write this two separately. So first of all we have u1 as x1 1 1 transpose, u2 as x1 minus 1 plus root 3I by 2 minus 1 plus root 3I divided by 2 square transpose, and u3 as x1 minus 1 minus root 3I divided by 2 minus 1 minus root 3I divided by 2's whole square transpose for all x belongs to R. So this is the solution for given question. Next question we have, if A is equal to 1 0 1 0 0 2 0 0 3, then find eigenvector or eigenvalues A. Now for the solution, to find eigenvalue of A, we have determinant of A minus lambda I is equal to 0. So we have 1 minus lambda 0 1 0 minus lambda 2 0 0 3 minus lambda is equal to 0. On simplifying this we will get 1 minus lambda 3 minus lambda minus 0 minus 0 plus 1 into 0 is equal to 0. So we will get 1 minus lambda into minus of lambda 3 minus lambda is equal to 0. Simply I can say that 1 minus lambda is equal to 0, minus lambda is equal to 0, 3 minus lambda is equal to 0. So lambda is equal to 1, lambda is equal to 0 and lambda is equal to 3 are our eigen values. So eigen values are lambda is equal to 0, 1 and 3. Now corresponding to these eigenvalue, we have eigenvector as for lambda is equal to 0. To find eigenvector for lambda is equal to 0. So a minus lambda I x is equal to 0. So we have a as 1 minus 0 1 0 1 0 0 2 0 0 3 x1 x2 x3 is equal to 0 0 0. On solving this, x1 plus x3 is equal to 0, 2x3 is equal to 0 and 3x3 is equal to 0. This implies x3 is equal to 0 and x1 is equal to minus x3. So but again our x3 is also equal to 0, so x1 is equal to 0. So u1 is equal to x1, x2, x3 is equal to x1 and we have 0, x2, x2 and x3 is also equal to 0. So we have x2 0, 1, 0. So this is our eigenvector 0, 1, 0, or we can write this as u1 is equal to x2 0, 1, 0. This x2 belongs to R. Next, for lambda is equal to 1. Again, a minus lambda is equal to 0 into x is equal to 0. So we have 1 minus 1 as 0, 0, 1, 0, minus 1, 2, 0, 0, 3, x1, x2, x3 is equal to 0, 0, 0. On solving this, we will get x3 is equal to 0, minus x2 plus x3, 2x3 is equal to 0, or 3x3 is equal to 0. So x2 is also equal to 0. Therefore, we have u2 is equal to we have x1, x2, x3's transpose. This is equal to, we can write in this way also, x1 we don't have, so x1 remain x1, x2 and x3 are 0. So this implies x1 1, 0, 0. So this x1 belongs to R. So this is our vector u2. Now for u3, for lambda is equal to 3. So we have 1 minus 3, 0, 1, 0 minus 3, 2, 0, 0, 3 minus 3, x1, x2, x3 is equal to 0, 0, 0. This implies minus 2, 0, 1, 0 minus 3, 2, 0, 0, 0 is into x1, x2, x3 is equal to 0, 0, 0. So we have minus 2x1 plus x3 is equal to 0, minus 3x2 plus 2x3 is equal to 0. So x2 is equal to, we can write, first of all 2x1 is equal to x3. Then from this we can write x2 is equal to 2 by 3 x3, but x3 is what? 2x1. So 2 by 3 2x1, this implies 4 by 3 x1. So we have u3 as x1, x2, x3. This implies x1 is equal to x1, x2 is equal to 4 by 3 x1, x3 is equal to 2x1. Therefore x1 1 4 by 3 2, where this x1 belongs to R. So these are the three vector corresponding to 3 eigenvalue. We have 3 eigenvector. These are the next question for which you have to find eigenvalue and eigenvector. First of all, we have first matrix as this, second one, and we have third one, 4, fifth and 6, this is 7 and this is 8 matrix. So you have to calculate eigenvalue and eigenvector for this 8 matrix. Now we'll do one small question. We have to calculate eigenvalue and eigenvector for given linear transformation x minus y, x plus y. Solution. We have to find eigenvalue and eigenvector. So we have matrix as 1 minus 1 1 1. Now according to this we have to calculate eigenvalue. So a minus lambda I, determinant is equal to 0. This implies 1 minus lambda 1 minus 1 1 minus lambda is equal to 0. This implies 1 minus lambda square minus minus 1 become plus 1 is equal to 0. On solving this we will get 1 minus 2 lambda plus lambda square plus 1 is equal to 0. On further simplifying this, we are getting lambda square minus 2 lambda plus 2 is equal to 0. On simplifying this, we will get lambda is equal to minus minus plus 2 b square plus and minus under root b square means 4 minus 4ac minus 8 divided by 2. So this become 2 plus and minus under root minus 4 divided by 2. So this become 1 plus and minus I. So we have eigenvalues as R, lambda is equal to 1 plus and minus I. So we have L of xy is equal to x minus y, x plus y. Then we have to calculate eigenvalue and eigenvector for this. So we have matrix A as 1 minus 1 1 1. For this we have determinant of A minus lambda is equal to 0. That is determinant of 1 minus lambda 1 minus 1 1 minus lambda is equal to 0. On simplifying this we are getting 1 minus lambda's whole square plus 1 is equal to 0. 1 minus 2 lambda plus lambda square plus 1 is equal to 0. This implies lambda square minus 2 lambda plus 2 is equal to 0. On finding its root we are getting plus 2 plus and minus under root 4 minus 8 divided by 2. This is equal to 1 plus and minus I. Now to calculate eigenvector we have to find eigenvector. So we have A minus lambda I, x is equal to 0. So we have 1 minus 1 plus and minus I, 1 minus 1, 1 minus plus 1 plus and minus I, x1, x2 is equal to 0, 0. So this is equal to plus and minus I, 1 minus 1 plus and minus I, x1, x2 is equal to 0, 0. So this is equal to plus n minus I x plus x1 plus x2 is equal to 0. So, and for next one, minus x1 plus n minus x2 is equal to 0. Now, to calculate first one, suppose we will do calculation for plus 1. So, first one, plus x1I plus x2 is equal to 0. This implies x2 is equal to minus xi, and this become minus x1 plus n plus x2 is equal to 0. This implies x2 is equal to, this remains same, so no need to do this. So we have u1 is equal to x1 and x2 is nothing but minus of x1I. So we have x1 1 minus I, where x1 belongs to R. For second one, minus xi plus x2 is equal to 0. This implies x2 is equal to minus xr. So u2 is equal to x1 x2. This implies x1 is x1 and x2 is equal to minus I. This is plus, so plus x1I, x1 outside, so we have 1I, where this x1 belongs to R. So these are the questions based on eigenvalue and eigenvector. I hope you understand this concept.